Thank you for joining us for Going Green, Connecting Sustainability with Remediation Success. My name's Sebastian Harrison with the Center for Creative Land Recycling. My background, I'm an environmental engineer and brownfield specialist with the group. Really excited to join with this panel today. It can be kind of shocking to some people that environmental cleanups can be incredibly CO2 intensive. So the question we ask here is how can we do better? How can we look at all three dimensions of sustainability, ask the right questions, explore the different technologies, and just to try to implement an approach that can make more sense for the communities around these areas. So joining me today, we have Mital Desai with Geosyntec, who's going to begin our panel with an overview of sustainable remediation technologies and some practical applications, and really try to give you some tools for project management as you go back to your sites. Followed by Navarro, who's going to present to us a specific case study with, again, some real examples of what sustainable remediation can look like. I think we all know that sustainability can be one of these loose terms that's hard to define. Really it depends on the project that we're looking at, Unfortunately, Andreas Martinez of DTSC could not join us today. So I'm going to do my best to introduce some of the great work that he's been doing and walk through the material on how we engage communities through workforce development, especially how that can tie into cleanups. And then finally, Greg Neal is going to provide a regulatory perspective of sustainable remediation. Just the important considerations in how you can get your regulator on board to make a sustainable approach happen. They can oftentimes be that piece, your biggest advocate, and really, taking a project to the next level. So with that said, I'm going to pass over the mic to Mital Desai.
Thank you, Sebastian. Can everybody hear well? Okay. I'll try and keep you awake after a nice lunch. So I'm going to quickly talk about a variety of things as we introduce this concept of sustainability. So what is actually a sustainable remediation? And then I'm going to give you some examples of sustainable remediation technologies that Geosyntec colleagues all over the world or all over the country has implemented. Some of the practical tools that we have used to evaluate sustainability, and there are lots of them out there. And then I really wanted to give acknowledgements to some of my colleagues for sharing their work, which I'm presenting here today. So what is really sustainable remediation? I think in a very, very simple term, we are reducing the collateral damage to the environment. Opportunities really exist from the start of the project to the finish of the project. There are so many phases in the project where you can think of sustainability and really, implement those aspects as you learn more and as you adapt more. The three primary pillars, and this is one of the misconceptions, people always tie sustainability to, it's all about environment, but that's not true. It is about economic, social, and environmental, which are very important pillars. And just to kind of think of our history, human beings have always, always, always wanted social and economic development no matter what. All you are adding is in chiming with environment. So the economic social aspect is definitely in place. What are the core elements of sustainable remediation? What are you really trying to achieve, right? So you're trying to save energy, right? In very simple terms. Of various treatment systems. You are trying to reduce air emissions. You're trying to reduce water requirement, impacts on natural resources, and so forth. You're trying to make the land ecosystems more sustainable and better. Material consumption and waste generation, you're trying to reduce them as much as you can, and basically long-term stewardship action. So with that, I'm going to share two examples of a sustainable remediation technology, the first one being in situ bioremediation. And I know it's a pretty common technology. Many of you here may have used this technology. But what is really the ISB, or in situ bioremediation? It really enhances the native organisms to work for you. You don't have to work that hard. Let them do the job, but help them get the food and the energy they need to do their job. Why is it really sustainable? Because it really eliminates management of massive secondary waste streams, like often GAC, generation of soil disposal, all of sludge. So that's all waste that you typically generate, which you don't in this case. It reduces additional worker exposure because when you have treatment systems, you have operation and maintenance, monitoring, optimization, you're exposing workers on all those different hazards, which you pretty much eliminate in this case. Air emissions, you significantly reduce, again, because you're not using treatment systems, massive treatment systems that are responsible for air contamination. And then large above ground facilities. You don't have massive facilities that takes away a lot of room and space. It definitely reduces, I can't say it eliminates, but it definitely reduces an energy consumption. There is some amount of energy for sure used in this technology. It can be implemented in the source zone or really off-site as your groundwater migrates, for example. Can be aerobic, anaerobic, and oftentimes it culminates into monitored natural attenuation, which is kind of the perfect spot, which is dream for every consultant and client to be in, that you have to do as little as possible, and the subsurface takes care of itself. I'm going to talk about a former furniture manufacturing facility here in California. So this is a TC Plume, which is related to a clarifier of that furniture manufacturing facility. And at the core, as you see, the concentrations are above 500 microgram per liter. And so at this particular site, we thought using enhanced in situ bioremediation would be a great remedial alternative. So here are the key features of this particular remediation. There was one extraction well involved, which you see probably at the bottom. There was one re-injection well involved and a whole bunch of donor wells surrounding the re-injection wells. And then a recirculation system, which basically pumps out the water and pumps in the water. In this particular case, the yellow circle that you see was our extent of recirculation of groundwater. We basically extracted the groundwater from that area, injected lactate to really get it more in the reduced condition, injected back in one of the re-injection wells, and around the re-injection wells, we injected donor and KB1. So this nice recirculation system kept recirculating the water for almost a couple of years and really spreading the donor and KB1 all across the recirculation cell. And so following about 4 rounds of injection, 2 years of recirculation, this is the data we got. So as you can see, 2008 really shows the bullseye of more than 500 microgram per liter. 2001, it reduced to less than 100. And in 2015, 5 microgram per liter. So we were below the MCL. So now was the time when we really saw a lot of M&A parameters or M&A evidence. And the regulatory agency was happy for us to, really turn off all the remediation systems and just perform M&A. So in summary, we eliminated the treatment media cost, which is really pretty expensive, comes with pump and treat system. We use natural bacteria instead of, treatment filter. Left the groundwater in place instead of taking it off and removing it out and discharging it, right? And it definitely had a lot of reduction in energy consumption. And then, of course, air emission. I'm going to now talk about an example of a phytoremediation, and this is one of my favorite, actually. So what do you really need for phytoremediation? It's very important to characterize the site appropriately from a phyto perspective. And from a phyto perspective, as in where the root zone of the plants are, the plants that you are planning to use, where the contamination is, what's the extent, and how will those specific species of plants really help you. So in addition to just delineation, you really want to understand from a phyto perspective as well. The impacted media, of course, should be accessible to root zone. A lot of California sites, our groundwater contamination is more than 300 feet deep, so it's not really applicable to all the sites. The expectation should be reasonable. Phyto does not clean up in a day or in a few months. It often takes a few years to multiple years. There's a site preparation requirement on how you would properly install that well, but that comes with any remediation system. The relative cost of installation is pretty low for Phyto, so that's a huge advantage. It's relatively easy to install. You're just installing plants and trees and stuff like that, so pretty straightforward, easy. And it has ability to remove both soil and groundwater. So oftentimes we think that Phyto can only be used for groundwater, but it can be used for soil also if you use appropriate irrigation system and fertilization. It can be successfully used. There are some key parameters that one should keep in mind while designing Phyto. You really want to incorporate resiliency. And when I say resiliency is try to grow native species of that particular area. You'll be more successful in doing so. Try to put multiple species in the ground, so in case one particular species is not as resilient as the other, or for whatever reason doesn't like site-specific parameters, weather, climate, then you still have other species to lean on. So go with multiple species. So incorporate diversity. And then anticipate and plan design for, sort of extreme climates, heat, wind, storm, and so forth. I'm going to talk about a former electronics manufacturing facility as a case example. So quickly to give you an overview, this particular site had, chlorinated volatile organic compounds, 1,4-dioxane arsenic in the groundwater, which was pretty shallow. And there was a pump and treat system ongoing for many years using UV and peroxide. And 25 plus years to reach remedial goals, and the client thought, oh boy, let's look at an alternative. This is going to take forever. Also, the interesting thing about this site, as you can see, that arrow is the groundwater flow direction, and you probably see a pretty small line, but those are residences. And so the groundwater was flowing in the direction of residential neighborhood. So that was one of the reasons why it was bothering the client and wanted to get a solution, something better than pump and treat. So Geosyntec installed a phytoremediation system at this particular site. We started with 154 tree wells, which were installed in 2013. There were some invasive species in the area, which we removed, and we planted some native species as well. The cost to implement, this is an interesting statistics, was really the same as 1 year of O&M of the pump and treat system. So really huge saving. And then to show you some results, the top left photograph shows you that after planting within almost 18 months, the groundwater gradient changed. Now from going towards the residence, it's kind of contained and now kind of staying in the vicinity of where the source was. As you can see the map below, 1,4-dioxane within the planting area drastically reduced concentrations in about 9 months of growing the trees. And then outside the planting area, which is further down gradient, we also showing a really good decrease in concentration. So with this success, just imagine, we had UV, oxidizer, stripper, GAC units, all of that as part of pump and treat. We moved to something that was just a tree, a beautiful tree. And it really helped site closure in 2016. Some of the goods that I would like to pass across to all of you is it eliminated costs related to energy, right? Hydraulic control and decreased groundwater concentration. Hydraulic control was pretty impressive at this site, almost pretty much in less than a year time frame, which was very good. You're sequestering CO2 and improving greenhouse gas footprint by planting trees instead of pump and treat. Trees are definitely more aesthetical than pump and treat system, right? And the regulator was happy, the client was happy, and site closure in 2019. So this was a very good success story. A quick overview on the cost estimates between the pump and treat and The tree well technology, as you can see, there is a massive difference, 4.2 million versus 1.7. So that's a lot of cost saving. Now, I'm going to talk about quickly some tools that you can evaluate, that you can use to evaluate sustainability. And there are a lot of them out there. So ITRC guidance has 34 tools. They come in broad range of platforms, technologies, input data, learning curve, cost estimates, and whatnot. So you need to consider those things as you select an appropriate tool for your analysis. Again, this is a snapshot of all the kind of tools. What I'd like to show you is one of the few examples of how we use those tools. Okay, there's this industrial park. Okay. There's this industrial park in Washington where we evaluated 3 different technologies: M&A, pump and treat, and permeable reactive barriers. We used the AFCEE tool, which is developed for really matrices such as air emissions, helps you to evaluate CO2, NOx, SO2, and so forth. Energy helps you understand how much energy you are saving. Safety and accident risk, which is very important. And then the cost, which is, I think, the most important for all of us. So these are some of the input parameters for the tool. Pretty standard: travel statistics, number of wells, sampling depth, duration, decay rate, and so forth. So when we plugged all those data input, here is kind of a summary of what you see. And we ran sensitivity analysis, obviously, because a lot of parameters are sort of assumptions and standard values that you get out of literature. So we really ran sensitivity analysis, and it shows you a range of CO2 emissions, energy consumed, and safety accident risk for each of the treatment technologies. And clearly, M&A was the winner. And we could sell this to an agency, and the agency accepted M&A. Of course, there were other lines of evidence also supporting M&A, not just the evaluation. Now, other uses of sustainability tools, like I said before, you can use the sustainability tool during the entire life cycle of the project, and not necessarily just at the beginning or at a specific stage. So for one particular project, we were running an SVE system with thermal oxidizer. And as you know, thermal oxidizer has fuel requirements. And as you start dropping your concentrations of chlorinated compounds and petroleum hydrocarbon, thermal oxidizer is no more very effective. At which point, we really performed an analysis using one of the sustainability tools and help agency understand that it looks like it is time for us to switch to rebound test, even though we can probably use a little bit more, but it doesn't make sense to go from oxidizer to carbon and then rebound test. We can go rebound test right now. So we proved it to the agency, and as you can see, it reduced the operational time by 90%, more than 1,000 tons of CO2 emissions a year. And the operation cost went significantly down, and safety exposure went down by 490 hours a year. So all of those were savings. Another example is groundwater optimization. So at one particular site, we had 378 wells that we were monitoring on quarterly, annually basis, and that's a lot of wells. So we did perform optimization evaluation and said, which ones do we really need to understand the groundwater flow characteristics? And we decided, or we came up with the conclusion that 170 wells were enough. We provided, again, this evaluation to the agency, helped them understand where we were going, and saved about 80% of carbon footprint annually, and again, safety exposure by 80%. The last but not the least, one of the LNAPL recovery system where we were really using total fluid recovery, which is like automation, automatic pumps. We realized that system was not sustainable anymore because it uses electricity. Again, help the agency understand why we can change it to something else, and we reduce CO2 emissions by 4 metric tons a year. And again, I would like to acknowledge my colleagues all over the country, because not everything I spoke about is my work. I gathered information from all my colleagues, so thank you so much for sharing that information with me. Thank you. I would like to invite Louis as the next speaker for the session.
Okay. So avoid the middle button at all costs. All right, great.
Stop reacting, look at me, and just go.
I'll be the person looking at you with a big sense of fear in my face.
You got a clicker with a freeze button.
Yeah. All right. Well, good afternoon, everyone. My name is Luis Navarro. When I was discussing this panel with Sebastian about sustainable remediation, a lot of us will think about green remediation as sustainable remediation. My background includes a long history of environmental assessment, remediation, as many people in this room. But within that also, I have done sustainability consulting. And sustainability is really much more than just protecting and reuse of the Earth's resources. There are other elements that we need to consider. And I'm going to tell you a story about a site that we've had a significant impact, not just on finding ways to minimize the environmental issues arising from our remediation of the site, but also some of the social impacts. As a sustainability consultant, one of the things that you learn is that it's not just about creating a sustainable object or a sustainable service, but that you can apply sustainability principles to basically anything you do, and you start thinking through the process and finding out how you can apply these principles so you can take something as basic, and we're going to talk about a project that is a classic dig and haul project. Not much exciting about that, doesn't sound very sustainable. But if you apply the principles, you can actually find ways to really minimize the environmental impact, but also start to measure some of the other important elements. Along with sustainability, a lot of us are hearing the new acronym. It's not that new, but it's really starting to become known through the public. That's ESG. So ESG is environmental, social, and governance. And it's measuring organizations as well as projects against those three different areas. So it's no longer just about the environmental impact. We're going to talk about the social impact of a site that we have been able to recover and bring to life again, and the impact that it's had around the surrounding community. So I hope that you'll enjoy it. So I'm going to start off, before even talking about the site, is why should we care? Why should we care about revitalizing sites, beyond from just finding a way to remove the contaminants, or at least remove them from an area where they would be in direct exposure to a sensitive receptor? And these are normally associated with large businesses, large industries that have historically used the site. So I'm going to tell you a story about a site that a large business appeared for a geologic resource. So we're going to talk about the Riverside Cement Company site out in Jurupa Valley, California. And back when this site was developed, we're going to see some pictures of it, 1906, there was nothing out there. There was no community. In fact, there was a rail line that was put in around the time that the cement company at this site started to operate. Not necessarily to take cement out, but to bring workers in, because there wasn't even a surrounding community. And the cycle that we saw occur at this specific facility is something that we've seen throughout a lot of different neighborhoods and communities in our state, in our country, and globally. So that's what we want to talk about. When I say, so a large business comes out, creates employment. It's significant enough to create a community. So you start bringing people in to do the work, but then they say, hey, we'd like to start living throughout the area. The community starts to build up. The community thrives. There's a great source of employment. And then environmental impacts and different economic pressures start to make it so the industry cycles out. The actual creation of employment cycles out. And then the community is forced to do one of two things. It'll either evolve or it's going to suffer. So as we all do remediation, we've also started to hear a lot about environmental justice, right? And justice for the surrounding community. So we're going to talk about a successful story that we're trying to help that community and create revitalized asset in this area to create employment opportunities for them. So how do we close that loop and start creating employment? So the Riverside Cement Company Crestmore facility started operations back in 1906. This picture is from approximately the 1970s, when the mine was still operational. At the time, it was actually underground mining, though the site also has a history of quarry mining, of surface mining. One of the people that helped pull together this information is actually in that picture. He has since retired, and he was the last employee of the Riverside Cement Company Crestmore facility. So, to bring in the story of why this site is relevant, if we look at the location, it is up in Jurupa Valley, which is very close to both the 10 and the 60 freeways. It is in an area that the cost of land is relatively lower than a lot of the land that is closer to the major port system of Southern California, which is the Port of LA and Port of Long Beach, which together make the largest port in the United States and the third largest in the world. So as we move towards e-commerce, there's continued economic drivers to get more materials out of some of the different countries internationally through the port system, get them in onto land, and get them into large warehouses, help sort them, and then distribute them out through the rest of the country. So that's our economic driver for this site. Here you can see the site, this initial picture of 1906. There you can see the Riverside Cement Company, and there is nothing around it. Now behind that, if you look along that slope, that's filled with different commerce as well as residential. But at the time, there was nothing. There was just a rail line to bring people in. And in the 1980s, you can see now it was a 300-acre large site with several surface mines, an underground mine system, large drying areas up to the northeast of the site. And as you can imagine, with mining operations dating back to 1906, the environmental concerns were not there. So we have found buried material all over the place. And just to give some context, what we have found, some of the main contaminants related to these operations are metals. So you're talking about hexavalent chromium, lead, arsenic, mercury, and these are contaminants that are really hard. There's not many options that you can do in situ, or you can do necessarily a green remediation for. You're really limited in the options you have. So it goes back to the essence of thinking sustainably. How can we apply maybe a traditional approach, but find ways to make it more sustainable? All right, so here's a little bit of the history. In the 1980s, the mining operations actually stopped. They had subsurface mining, and this was really interesting. There is a lake on the site that is visible there in the smaller picture. You can see it down to the bottom of that picture. There is Crestmore Lake, but that did not exist. And there's a picture in 1980 that shows it's not there. There's actually an old quarry, and the underground mining, they went deep enough to where they eventually penetrated groundwater and released artesian pressure from the groundwater, and it actually created the lake. At that point, they decided, hey, maybe we should stop mining. So they stopped mining, but they continued to do cement manufacturing. All the way through about 2014, the site ceased operations, and you're taking an area that used to create 500 to 1,000 estimated jobs to now just one individual, which was the individual that helped us pull this together. So, and you have a surrounding community now of people that are looking for ways to keep themselves gainfully employed. So the transition, what occurred here? Our client had a vision, they're a redeveloper, and they saw that the economic need that we talked about from the port system and e-commerce, and so they proposed this and got this approved through the city. We did a CLARA process, a California Land Reuse and Revitalization Act, with the DTSC, and have had a fantastic time working together with the DTSC. A good friend that I made there with Rafat, who we presented this site in the past. But we're going to talk a little bit here in the future about the importance of, to get this done, about collaborating and everyone focused on the same goal instead of the traditional pathway of people pulling in their own directions and thinking that they're at odds. So anyways, these are going to be e-commerce supported, and they're going to create employment. And they're going to create jobs that are actually coincidental or aligned with the skill set of the surrounding community. You think warehouse jobs, are they the best jobs? No. But could you imagine with the surrounding community if we put in an R&D facility for pharma? That doesn't match very well with the surrounding community skill set, and you're going to have something that we're starting to see, not starting to, but that we've seen throughout Southern California, gentrification, which creates a whole other series of social challenges. So there's a good match actually here with the surrounding community. So we start to see this opportunity that we're creating a sustainable solution through solving social issues for the community. Here's the redevelopment plan. So we're going to have these sites. They're going to be, it's going to be physically attractive to look at. Historically, the mine operation, if you can imagine, from 1906, when I first got to go to the site, it looked like a scene from, I don't know if everyone's ever seen the Mel Gibson movie Mad Max and Thunderdome and everything, where it's just this desolate desert landscape with just broken down machinery, and it's going to be converted to that. So for the community, it's also going to be, there's visual benefit. And so our remediation, so we have all of these different materials that were buried throughout the history that have high lead, have high arsenic, have high hexavalent chromium. But when you talk about metals, and we start to think about what are the exposure pathways that metals can get to a sensitive receptor. Because just the presence of a toxic material in the media isn't necessarily contamination. There needs to be an exposure pathway to where sensitive receptors can be exposed to levels that can be that can negatively affect them, whether they're human health or whether it's ecosystems. So we started to contemplate that, and we started to look at the grading plan that we had for these, because metals also, there are some exceptions when they're metallized, but most of them are not volatile. So you're not going to have soil gas issues. So it starts to become direct contact. Well, how can we mitigate that? And then we also have to think about protecting groundwater. So we created our conceptual site model and started seeing that an option, instead of taking this, these earthworks, and for a point of reference, the amount of material that was moved as part of the grading operation here, 2 million cubic yards of material to get this site built, a 300-acre site. So that's quite a bit of material. And if we even have a 1% of that material being impacted and having to go off-site, you're talking about 20,000 cubic yards of impacted material, doing GHG emissions as you're trucking them off to another facility, increasing the risk of exposure to public health in case there is an accident along the way, GHG emissions, and then also the other aspect of taking things to landfills is landfills, will actually be lost land. So it's land that is now given a purpose of maintaining waste instead of finding some other beneficial use for society. So it's not a sustainable best practice. So we started going through that and working with DTSC. We found that there were deeper areas where instead of making this a waste, we can actually create this, and we found geotechnically it had the properties to make this fill. So if we had it fill and we had it at a safe distance from any sensitive receptor, we're removing the potential for an exposure pathway. We are protecting public health, therefore accomplishing the DTSC's primary objective, and we're creating fill that's going to help let this project come to life. And by doing this, obviously there are also savings that helped make this project pencil in, so that there's actually developers and investors that are willing to invest in this and create this opportunity for employment for the surrounding community. So you see it starts to come full circle. And that's the real concept around sustainability. It's not just the environmental, it's bringing in that social aspect as well. So to do that, we really had to come together, and this is what I had mentioned previously, is bringing the different stakeholders and finding a common goal and a common vision. And through all of our decision processes, focusing on that and making sure that our decisions are aligned with those objectives. So it helped the developers and us as their consultants understand that we really have to provide, if we're going to use this material, it has to be at a safe distance, it has to be in an area that's not going to be intercepted. If there is future earthworks down the way, we had to foresee what are the controls that we're going to implement to make sure that future workers will be protected and that the regulators will be involved so that they can make sure that public health is still being protected with what is known, not today, in the way of potential hazards, but what is going to be known in 15, 20, 30 years down the line, that obviously we have no way of understanding at this point. So we built in controls through land use covenants about notifications to make sure that future earthworks or future development at the site will still, there is a way to make sure that the DTSC is involved and that we can continue to protect public health. So that's how we started bringing it all together. Everyone had a shared vision and we're able to see the project through. So we've now got the project pretty far along. We've got one of these buildings built. Several other have foundations. We have moved about 2 million of the cubic yards and we are now going vertical on the site. And there are now tenants that are about to move in within the next few months. And tenants are going to need workers, employees, absolutely. So there you go, and you start to revitalize. And so the surrounding community is excited about this. So here's a little bit about the estimates that we had for jobs. Starting wage, again, these are warehouse jobs. They're not necessarily great. I had to pull out some of the information. But when you look at a 17 to 25 hourly wage, it was a significant increase based on the average wage of the surrounding community at this time. So there was an improvement for the surrounding community. And bringing it back to close it up, why should we care? These are some of the benefits that this project has created. So we found ways to not just do environmental best practices, keeping these materials on site, and using them as fill, as a sustainable source of fill, but also created the social impact for the surrounding community. Thank you. And now I'm going to hand it over here to Sebastian.
Oh, cheers, great job. Enjoyed that.
Okay, thank you everybody, and thank you Mital and Luis. Great presentation so far. So I have the honor just to talk through some work that Andreas has been recently leading, involving workforce development in communities, and especially how we can engage with regards to cleanup work. State agencies, departments, boards, and departments have a unique opportunity to identify how to get the gears of government moving, and how to benefit communities outside of the traditional goals of the projects. Currently, DTSC is focused where cleanup sites can make good candidates for these employment opportunities. You know, understanding that there are multiple factors contributing to the environmental burdens in a community requires a unique approach to achieve environmental, social, and economic justice. Workforce and training programs are vital tools to achieving these justice goals. And really the huge piece of how we pick up these programs and make them work is by engaging the community and having that dialogue. You know, to understand what the need is and to meet them where they are to identify these inequities. You know, what's being seen by the community. You know, we should ask these questions, you know, from beyond just an economic perspective, but also an environmental and a social piece, you know, at the local and regional area. You know, this is where we seek to establish the programs that produce the tangible outcomes for social equity and economic growth. You know, providing jobs with prevailing wages to these people and communities is vital to make sure they are able to earn a living wage for themselves and their family. You know, I think we all know in this room, and this is the value of coming to conferences, that partnerships are vital here in really making a project a success, especially when you're trying to engage work where you might not be familiar with the locals. What are these nonprofits? What are the labor unions or the training facilities that you can leverage to make this work? Each partnership can really bring a unique set of resources that can be leveraged to help in these cases. And again, just to revisit, having that good community dialogue where you're able to get the regular feedback, really able to meet people where they are, understanding, what type of training is necessary, and to really go beyond just the programmatic goals to, how can you sustain what you're building in the future. Okay, so thank you all for listening. If you have any questions or you're more interested in learning more about this program, please contact Andreas. His contact information is right there. I'm going to hand off now to Greg Neal, who's going to give a regulatory perspective on sustainability. Thank you all.
All right. My name is Greg Neal. I'm a senior engineering geologist with the Department of Toxic Substances Control right here in the Cypress office. There's something that I like to call the sustainable sweet spot, which you've heard from everybody that's already spoken, is that perfect alignment between the environmental needs, the economic needs of the area, as well as the community members or the social part. My goal here is not to try and profess to give you the answer of how to work with your regulatory agencies. Sorry about that, guys. Because there really isn't an answer, right? Each project is unique. All of the projects we've heard about here today are unique from one another, and every project into the future will be equally unique. But the good thing is that both the California Environmental Protection Agency as well as the Federal Environmental Protection Agency have been thinking about the sustainable remedial opportunities for a really long time. DTSC's green remediation guidance was actually originally published in 2009. So a lot of years ago, really, when you start thinking about it and the advances that we've made since then. In 2011, there was a huge push by EPA and other entities to bring more conversation and more effort to the topic. I actually like this figure out of the 2011 ITRC guidance because even then, 2011, here we are 11 years later, we're still kind of stuck in that middle part. That was the present in 2011, and I'm going to say that's the present here again in 2022. When you're working with within a regulatory framework, the honest truth is sometimes we struggle to consider those social and economic needs when we're really working through protection of human health and the environment. So how is it that you can create a sweet spot when you're stuck in that present? And really the honest thing is through a lot of honest, patient, and extensive conversation. There's really no other way other than to sit down with your regulator, bring those of you that are consultants, bring your client in and have that full conversation with everybody in the room at the same time. It really can't be a consultant-regulator exclusive conversation because we need to think about those kinds of things, about what are future reuses and things like that. Sustainability, when you're considering sustainable options, there's a lot of criteria. Are we reducing the toxicity? Are we reducing potential exposure pathways with I was going to say residents, but it's not always residents. Just plain reducing the exposure pathways. Are we affecting the volume of contamination? Through our process, are we creating a larger volume of contamination, maybe at a lower concentration? These are all things that we have to consider. And in the end, the answer is a balance of all of those things. I'm not going to highlight projects in the same way that you've heard before, but this is actually a project from 2006 that DTSC worked on. This was a pesticide and herbicide manufacturer directly adjacent to a railroad line, which clearly serviced the property when it was in operation. there was widespread contamination with herbicides, pesticides, as well as metals. And so we very well could have just scooped it all up, put it in trucks, and sent it off to a landfill. Back in 2006, I'll be honest, I wasn't in a place where I was like, yeah, this potential sustainable project is going to absolutely work. But what we did is we had those difficult conversations, and we built in flexibility so that we could try these things. And we worked with a product that actually mixes into the soil and breaks down those compounds. In the end, we went from, you can see the yellow areas on the figure, those were all supposed to be removal areas, but with the implementation of this plan, we cut it down to just the little red areas. So places where we thought we were going to have to remove a bunch of soil, we didn't end up having to do that. And we could go on and on about trucks on the road and potential for accidents and all of those kinds of things, aside from we'd end up with a hole in the ground and we need to find fill for that somewhere. This piece of property was only about an acre, but we collected about 300 soil samples, which that's kind of a significant number of soil samples. It's not something that you might ordinarily, try and get in and get out. We collected a lot of soil samples. But what it came to in the end is we were able to do targeted removals versus some widespread removal process. And this same process has been used a couple of other times in the department. One in particular to take hazardous waste concentrations of pesticides and reduce them to non-hazardous waste levels. And a lot of it still got hauled off, but didn't get hauled off as hazardous waste. It got hauled off as regular municipal waste. So regulatory considerations. The S fell off the end. I don't know how that happened, but this is a list that's obviously quite reminiscent of the National Contingency Plan. This is kind of where regulators start, right? Is this process going to be protective of human health and the environment? And I know that's a significant topic that we get into these conversations. What exactly does that mean? Are we going to, just because it's no longer a threat to surface receptors, but we now have groundwater receptors and other things that we have to think about. We have to think about other regulatory agencies. DTSC is just one of the group of agencies in the California Environmental Protection Agency who, while we don't necessarily have overlapping jurisdiction, we do have other considerations that we take into account. Obviously, the effectiveness. Combining waste into a single location and putting it out of reach of receptors, that's a pretty effective method. Does it reduce toxicity? Maybe not, but the point is that conversation and the work together, we came together to figure out a path forward. Implementability. There are some, I'm sure that we could think of programs here in this room with all of your brain power that's something that it probably is the greatest thing we ever heard of, but we could never implement it because it's either too expensive or it's just not a feasible option. How much do these things cost? It's easy for me as a regulator to say, if it costs $4 million, cool with me, but that's not the way the world works. We got to work with developers and decide on things that we can actually do. Regulatory acceptance, that's the one where you just gotta be complete with your conversation. Your CSM has to be extensive. You got to make sure that everybody on the team understands. Sometimes that takes a little more explanation than you would like, right? That's just the way it is. Regulators tend to be a little more conservative, just because we don't want to find ourselves in a place where we have to go back somewhere. Community acceptance is becoming a bigger and bigger challenge. Our communities are learning a lot about our process. It's becoming less and less of that black box where it goes and the consultants and the regulators get together and make something happen. DTSC has a program that we're trying to jumpstart, our Technical Assistance Grant Program, which is designed in part or maybe even exclusively to provide communities with resources to help explain some of the work that we're doing. So it's not just, you know, a bunch of scientists and you know, administrators doing the work, that we can bring the communities together. And I like the point about local knowledge. You know what? I personally live in the Inland Empire. I know the Inland Empire really well. I don't necessarily know the LA Basin all that well. So to have that local knowledge that we can bring into our programs really is helpful. It's interesting because I didn't actually consider this a bioremediation effort, but in the end, that's exactly what this is. This is a project out in the Mojave Desert. They have a groundwater contamination problem, specifically with hexavalent chromium. They have an ongoing pump and treat system that has been pumping water out of the ground for years. Unfortunately, they don't have a sewer system out there that can handle that kind of water. So they literally put this water in tanker trucks, haul it all the way from the Mojave Desert down to Riverside, and they put it in the SARI line in Riverside, which, you know, there's all kinds of things that could go awry with that. But the idea is that we were planting I think these are willow trees, with the goal of training their roots to get to groundwater, and the trees would actually uptake water, creating a depression so that we didn't need our pump and treat system anymore. We could just use the trees. These trees were installed in like 2010 and 2011, and I'm sorry, 2015, 2015, and here we are in 2022, and the process hasn't actually taken hold yet, and it's not actually working just yet. So I'm going to get to patience on another slide, but one of the hardest regulatory things in my opinion, to get from a regulator is patience. You know, we want to get these things done as much as a developer does, and while projects will stay with us for a really long time, you know, it's also hard for us to get a regulator to make a decision that says, you know what, we're probably not going to see results from this for 5 or 10 or 15 or hopefully it doesn't take 20 years, but 20 years to train tree roots to dive deep in the soil and use groundwater. But in that particular case, an important point is that pump and treat system, the existing pump and treat system, is continuing to operate. So even if the trees don't work, if that doesn't ever come to fruition, then we have that comfort that the residential community that's in the vicinity of this, they're still protected. Out there in the desert, it's a little bit different than here in the basin. They literally drink first encountered groundwater. It's not the greatest water in the world, but it happens in lots of places. So how do you get your regulator on board? I think I said before that I don't have the answer for you. There is no magic bullet for me to stand up here and say, if you do these group of things, then you're going to be successful, because every project is a little bit different. But getting to that point about patience, you know, it's not just patience on the side of how long it's going to take to clean up, but also patience on the part of developers and community members and that sort of thing. Sustainable options require a combination of both qualitative and quantitative data. Regulators don't do that great with qualitative data. You know, we want to have numbers and see things. You might have to characterize farther than you might have ordinarily expected to. You might have to collect additional samples. Again, public acceptance. There is groups out there that would like every project to be cleaned up to unrestricted land use. Obviously, that's not what the property is going to be used for, but you know, they want to be able to have that flexibility. The characterization, again, needs to be thorough. Your conceptual site model needs to be clear and complete. Those are kind of hard things to do. When your conceptual site model, you know, there's unknowns. I mean, there is no way for us to be able to sample every bit of soil or every groundwater location at a property. So we got to work through that. Life cycle of a property, of a project. You got to think about it from beginning to end. There are things that happen at the end of a project that we very rarely even consider when we're initiating an investigation. Your regulatory agencies are dedicated to using these sustainable options. It may not be the first conversation that we have, but we are dedicated to doing that. So there are some challenges, right? You know, in my opinion, the term green remediation, you know, when I say green remediation to someone that's not in the field, they think, oh, you just put some solar panels on your pump and treat system and everything's cool because you're not using electricity. But it needs to be a much bigger concept. There are true worries about getting a facility into a permitted universe because of the choices we make. You know, does consolidating waste become a permitting issue? The answer isn't always yes or no, and there are opportunities in both cases. And then we need to think about those uncertainties that are coming in the future, things like sea level rise and wildfire resiliency. DTSC is in the middle of this huge effort. I say huge. DTSC is in the middle of this effort to determine how do we assess existing sites, let alone new sites, existing sites against sea level rise. We know that's happening. We have lots of sites that are in coastal areas, right on the water, and if decisions that were made many, many years ago are now potentially creating challenges for us. So the idea, you've heard it here today from a couple of different panelists, that, you know, let's consider reusing the materials that are on site. It's not always you got to get rid of it. Sometimes there are opportunities that you can take to reuse it on site. Clearly, we as a state, we need infrastructure built. We need the supporting structures. We want to rebuild communities. In doing so, we revitalize and give opportunities to those communities, not just for employment necessarily, but, you know, for their livelihood, just to make their lives better. And I think that does it for me. All right.
Okay, folks, I think we have time for one or two questions. If you could go to the microphone in the center if you do have a question, please.
Hi, this is Glenn Burks with Group Delta Consultants. I have a question for Greg, actually. Having worked on the ASTM 2893 standard guided greener cleanups, there is actually a guide out there published by ASTM that can be followed for greener cleanups. Now, it does not account for social and economic, because the team that did it, which I was a part of, did not have that expertise, but it was considered a first step. That was published in 2013. And my question to you is, would agencies, and I went on a speaking tour to try to get this out there, would the DTSC be open to using this kind of guide to, when you're actually cleaning up sites, enforce that people follow this guide, so at least it makes an incremental improvement. It's not perfect, it's that first step. But I'm curious if you were even aware of that, because we used your 2011. That was a fantastic first pass at that, and we started with that. So I'm curious what your thoughts on that are.
Well, I think the base answer would be that as far as requiring use, I don't think that we would necessarily go to the point where we would require the use of some particular process. But what I will say is any support that we have, or that we can use to make site-specific decisions, then everything's on the table. I personally, and I am not aware of any staff where we would say, nah, we're not going to use that guidance because we don't like it. You know, because everything has value and benefit to it. So if you have a situation where you're where you think it might be valuable, bring it to the team, and the team can, you know, use your site-specific team, not you know, an administrative site. You know, bring it to your site-specific team, show them the value, show them the benefit that they could potentially get out of it, and then, you know, work through it. Maybe there are aspects of it that get incorporated, maybe there are aspects that don't, but, you know, I would just stop short of, I think you said require use, but so I'll stop a little bit short of that.
If I may, it's written in a way, it's very general. It's something that allows the user a lot of flexibility, so it's not onerous on the user. And I think the feeling out there in the world, and I'm sure the other panelists feel the same way, is there has to be there has to be some sort of regulatory push that requires at least people to look and consider. It doesn't mean they're putting onerous requirements that they have to meet some sort of lead requirement, but it forces them to analyze their site and actually consider this and come up with a score. It doesn't mean they're going to be graded on it, which is how it's written. It was very carefully written to be a beginning first step. And my feeling, and I don't know how other people feel either, is that until the agencies like the DTSC and the water boards and the EPA start to say, here's a guideline that's been accepted, some kind of guideline, because there were a lot out there, ITRC, there's DTSC, the Navy had come up with one, Mital, is have one that's cohesive, that you say, use this guide, follow it, and let's discuss it, because otherwise it doesn't go into the mindset for every site that you have to consider exactly what you talked about. In our case, it's only the environmental, the green, that's why it's called Greener Guide. It's not considering the social and economic. To do that, you have the software that Mital, the sophisticated software, but that costs a lot of money and it's sophisticated. This is a very basic first step. So I'm just, almost like I'm pleading with people, get together and use one standard guide.
It's a great question. Sorry, is there any?
No,
I was just going to ask you if Mital or Luis had any comments or thoughts on that approach or just this idea.
No, just quickly, I agree with Greg. I mean, I think if it's another tool, that's good. I don't, I'm not a regulator, but I don't see how they could potentially require it as a guidance. I think there'd be other legislative requirements to get it to that level. But any guide is always helpful.
I agree.
Okay. Excellent. And we are coming to the end of our time, so I just wanted to offer all our panelists just one more quick question. What's a misconception that you believe most people have about sustainability or sustainable remediation?
So one thing I personally feel very strong about is people feel that sustainability is short term, or it's the trend right now and eventually will phase out. And I hope that's not the case, and I don't think that will be the case. 36% of Generation Z population all over the world are very, very conscious about the environment, and they really understand the climate change and effects of that. They have it right in their face growing up, which we were probably not aware of. So I don't think that is the case. That's one. The second misconception is sustainability is part of a strategy. And I think it is actually the fundamental of a strategy. It's not a part of the strategy. So anything we do, we should consider sustainability as the most fundamental element of coming up with a new strategy, not just for environment, but generally speaking in anything and everything.
Those are great points. And I agree. I mean, sustainability is definitely going to be around. There's already law in Europe that requires disclosure. And the SEC just put out a new ruling. They're proposing a new ruling that's going to require all publicly traded companies to talk about their climate-related actions on their financial disclosures. So the wave is coming, and it's not going away. I think one of the big misconceptions that a lot of people is that sustainability feels scary. It feels like kind of a foreign term. There's a lot of sustainability practitioners and experts and all that. And sustainability doesn't have to be that. It's principles based. It's purpose. It's doing what's right. So again, it's not just about finding that green remediation. It's doing whatever you're doing and evaluating it from your perspective of, is this good for the planet? Is this good for society? And finding those points that you can maybe make it better. And there, you're being as much a sustainability professional as anybody else. So just get comfortable with it, get started, and it'll come naturally.
And for me, maybe just to add to that a little bit is, the sustainability concept sounds like it's something different than what we've been doing for all these years. And I think the reality is that, all of us, by working in the environmental field, have been considering sustainability. Why else would we clean up a property? So it's not as scary of a thing as we might make it out to be. And the reality is all of you are probably already doing it in some capacity or another.
Excellent. Thank you all, and thank you everyone for joining. Oh, I'll take one more question. Yeah, go ahead, please.
So I'm aware that Cleveland developed their own Office of Sustainability because when I was on the private, I did a RFP proposal for the firm I was at to help Glendale come up with an Office of Sustainability themselves. So do you see that as a trend that maybe as cities are embracing sustainability, that Office of Sustainabilities within their jurisdictions, municipalities would be a big help? And do you see the difference in dealing with those cities versus others that don't have those resources?
Great question. Anyone? Oh.
Yeah, I can take that. I've got some experience with that. Now, it's a great question. Actually, the city of LA does have a chief sustainability officer, and they have a sustainability plan, as does the county. And a lot of different municipalities are starting to develop them. So there is, and as you look through their plan, it's a lot of the points that we're discussing, not just about the environmental impacts and how to be more sustainable with the planet, but also the social as well. So yeah, happy to discuss it, but there's definitely a proliferation at the municipal level of organizations forming sustainability offices and appointing chief sustainability officers.
Okay, thank you all so much, and thank you again to our panelists.